Hey guys, I've alluded to this in the past, and I was just given the go-ahead to publish or make a video on how to do this. But Strange Engineering has or will be releasing a front wheel speed setup that comes straight from them, so you don't have to do anything else. You know, you buy their kit and it's done. It goes right on their brakes, or comes right on with their brakes. It comes with a nice Hall effect sensor. I kind of helped them out with this to figure out what would work, and we tinkered with it for a little while. Sorry, pardon my terrible camera skills, but so there's your sensor, and it is threaded into the backing plate that mounts the caliper. So your caliper mount comes with a hole in it, comes with a sensor, and then there is a reluctor ring in the hub. So then it picks up the the front wheel speed via that reluctor wing that's already built in. So this setup's pretty slick. I tested it on a car. We went out and did some burnouts with it, and I will show you how to set it up in Holley software and kind of the data from it and how smooth it actually looks. So we'll be right back. All right, so we got our front caliper and all that, and the brakes all mounted up and bled. We've got our sensor threaded in there, and it's at a 30,000 gap. And now we need to wire it and program it. So what you'll do is open up your software, open up your most recent global config that you're working with, and go to the input-output ICF. If you don't already have the IO ICF, you need to go to Toolbox, add individual config, come down here to IO, and then just grab the blank IO. I'm not going to do that because I've already got it open and configured. So the first thing we need to do is create an input for front wheel speed. So I already put it in over here. Name it front wheel speed. It's a digital speed frequency input, and go to configure. So there is 54 pulses per rotation. I had it set up to display in mile an hour as opposed to RPM. So if you're going to try to use this for front versus rear wheel speed, make sure that this and drive shaft speed match mile per hour, or RPM. So the pulses per rotation is 54. The pulses to average on this is 1. I didn't want any smoothing at all in this. I wanted to be able to have, good clean, or see how good the data was going to be. That's the only way to really test it. I didn't want to smooth the channel. The gear ratio is 1.0, and the tire diameter is 28. So this is actually, we're going to see here shortly that they don't match up in a data log, because I fat fingered this, and it's not a 28-inch tire. It's a 26.5-inch tall tire. So you'll see the difference in a minute. But you put the height of the front tire here. So there's our input. The way I do this is I go to outputs, and I create 2 outputs, right? So we're powering and grounding, we're sending power and ground from the ECU straight to the sensor. So the output, right? So wheel G out, ground out, configure. It turns on anytime the battery is above 8 volts. And the 12-volt output is the same thing, a battery above 8 volts. So that sensor gets power once the ECU turns on. It makes for a nice clean way to wire these things up. And then you'd go into your pin map. I've already got them moved over, but front wheel speed, right? It's a frequency input, right? And then there's my outputs, wheel P out, wheel G out. So there's my power and ground, so you know where to pin them at. Use shielded cable and terminate your shield with the ground at the ECU, and cut your shield back from the connector at the sensor, and use a piece of heat shrink or something to seal it off from the elements. So you only want the connection for the shield made at the ECU, not out at the sensor. So it's very similar to how, exact same way you do a cam and crank sensor deal. But I just wanted to make note of that so you guys don't ask, well, what the hell do I do with this shield? There you go. So we've got our configured and everything. So let's take a look at a data log and see how well this actually worked. So my personal car was not running, actually still isn't, So a buddy of mine down the road with a Fox body, pretty healthy Fox body, I asked him to bolt this up and let's go out and do some burnouts. So as you can tell here, our vehicle speed is in blue, right? Our front wheel speed is in green. I changed the color just so it's bright and easy to see. And then RPM is in red, okay? So he grabbed, he kind of rolled in on the trans brake and then let go of the brake to just blow the tires off, because this is the easiest way to show you, you know, a variable difference here, right? So here's our rear wheel speed, right, in blue. Notice it follows RPM because it's spinning. Obviously, it spins, and then you know, we're in and out of the throttle, right? So we're in the throttle here, it spins, it shifts, and then it kind of gets a little bit out of control. The back tire is rolling at 110. The car is actually moving at 28 miles an hour, and you know, you're playing feather in the throttle with the TPS. Here's the TPS going up and down, trying to keep the car in line. And there's our front wheel speed, nice and smooth, right? So if we look, I just want to show this front wheel speed. There's no smoothing on this channel, and you know, so there's no smoothing in the setup of the sensor itself, and there's also no smoothing in the channel. So as far as if you wanted front wheel speed to be accurate, you know, if you're driving down the road or if you want to use it to, you know, clock how many miles or miles per gallon, whatever you want to use, this works really well. And it's the data is very smooth. Now, what I want to show you is the difference in scaling with what I was talking about before. Notice the car's done spinning, right? So if you notice, they're about 2 miles an hour apart, and that's because there's the wrong size tire put in here. So you can fudge that by either, obviously, you can screw that up by either putting in the wrong size tire or putting in the wrong gear ratio for the rear end. So that, you know, one way or the other, one of them is going to move off of each other. But overall, this front wheel speed setup is pretty slick. It comes with their, you know, front brake kit. They're doing them for Fox bodies. The engineer I worked with and spoke with said that, you know, they're going to look into other avenues and see what kind of demand is for other applications. But now that they've got the idea and the design down, it won't be hard for them to, you know, add more products to the lineup, I'm assuming. So I do not work for Strange. I am not a dealer for Strange. I am just giving you this information because I was reached out to by Strange and asked if I could kind of try to help them out. So that's what I did. If you want to purchase this, at the moment, I believe they're going to be putting them on the website here shortly. But at the moment, I believe you'll have to call Strange or call your dealer and have your dealer call Strange. And it'll be, you know, a two-order thing. I got to play with this a little while ago, but they've just gotten around to having all the parts in stock and finishing up instruction and you know, boxing it all up. So if you are interested in this, like I said, again, don't contact me. I'm not a Strange dealer. I can't sell you this. Contact your Strange dealer or call Strange directly. So anyway, hope you guys enjoyed this. I'm very happy with this setup here. I'll be using this setup just to display vehicle speed on the dash and a couple other little things, but I'm very happy with how this came out. So, all right. Hope this helped you guys out, and have a good one.